This is Shiva. So in the previous one, we saw the force acting between thin wire and a point charge, which are separated by certain distance, right? And since we can't treat a continuous wire, or here as they've given that is a uniform ring, so we have to apply point we have to take an infinite small element, and then apply Coulomb's law, and then take the appropriate limits, and then compute the whole force which is acting between the given continuous body and the point charge, right? So they could directly ask what is the force expression. So they rarely ask what is the force. Instead, they could ask variations on that. So for example, instead of actual positive charge here, they could put minus, and then if we put negative charge, yes, since this is total positive charge, this will attract this one, right? And when this positive charge comes here, right, and it won't stop there because of its inertia, because it has gained already some velocity, it will go here. But as it goes here again, this total body will attract that, and then this will come back. So about this point it will do SH, right? Okay, so we'll discuss all that. So first, if we see, I think you're all familiar with this derivation. This is a standard one. I actually explained this one in Telugu, and it's available in another playlist, electrostatics, right? So if you see force, right, due to all the elements, right, due to all the elements, this df sine theta component they'll cancel out, and the only remaining components will be df cos theta in this direction. So if you want total force acting on q point charge due to this whole ring, then we have to integrate this component, that is df cos theta, right? Df is the small force due to this small element which we considered acting on q, right? And that df is the small force, that is small Coulombic force, kq by r square. K, this q, right, this element charge, that is dq, that we got as q by 2 pi r dl. Q by 2 pi r, they could, as I previously stated, this is line charge density, right? Lambda they could directly give. So otherwise you can do it any method, right? It doesn't matter. So I've done directly by taking q by 2 pi r. So this is q by 2 pi r dl dq into, right, cos theta from here, adjacent by hypotenuse, right? Adjacent is this distance is x, and hypotenuse is root of x square plus r square, which I denoted with r, right? Kq by x square into cos theta, adjacent by hypotenuse, right, x by r. So kq 2 pi r, these are all constants. X is also, for a given distance, it is constant, excuse me. So integral dl this, so small element which we have taken is dl, and if we integrate the total, we'll get the perimeter or the circumference of the circle, so that is 2 pi r, so which that I have substituted here, and then we got this force expression, right? So I just stated that if x is very much greater than r, that is separation between the ring and the point charge is very much higher comparable to the radius of the ring which we took, right? In that case r is very much less, so we can neglect r. So x square whole power 3 by 2, 2 will cancel, then it will be x cube, right? And numerator another x is there, x cancel, so that will be x square. So this is just inverse square dependence again. So when they are separated by large distance, we can treat them as point charge, so directly we got this expression, right? So in another case, that is the reverse case, that is when r is very much less than x, right? X is very much less than r. This is the same case as before. X is very much less than r, right, as stated here. So we can neglect x, right, and then we will get this expression, right, kq qx by r cube. And by the way, as I said, I'm replacing this positive q with negative charge, then it will do SHM about the main position, this position, right? So in that case I will get this minus, right, And if I compare this with minus F is equals to minus kx, and this is restoring force, right? F is equals to minus kx, and where k is SHM constant, right? So if we do this, F is equals to minus kx, SHM constant I can equate it to this one, right? K q by r cube, right? And time period we know T is equals to 2 pi under root m by k. I substitute this one here, and this is the time period, right? Okay. So this is the time period of the session. They could ask angular frequency. They could ask frequency. Then you get the. Hope you got the point, right? Okay. So this is force. The same method we apply for electric field also, because both are vectors. We have to consider the angles also with which those things act on point charge. Otherwise, if it's just potential, then we don't have to consider angles because that's a scalar quantity, right? So another variation or another kind of question they could ask is, at what distance from the center, right? The maximum quantity acts. In this case, the maximum force, or they could ask what is the maximum field, right? So maximum thing. So since force is varying with respect to distance, right? So force expression is this one, kq by x square plus r square whole power 3 by 2. So with respect to x, force is varying, so I need a maximum force with respect to distance. So with respect to distance, that is with respect to x, I am differentiating it and equating it to 0, right? So if I do the differentiation, so I just applied u by v method, right? And then I got this one, right? So from here x is equals to r by root 2. So at x is equals to r by root 2 distance, we will get maximum force. So if we place point charge at this point on the either side of the ring, by the way, right? Plus or minus root on the either side. So if we place a point charge, the point charge somewhere around r by root 2 here or here, right? Maximum force will act on the point charge due to this whole ring. Okay, right. I hope you got the point. They could ask any other continuous body. For example, they could ask for a disk, right? Or they could put 2 point charges or 3, right? So any number, this is the same method, right? So since it's scalar, we have to consider this angles also, right? Okay. Right, this is more or less about continuous. So in the continuous bodies ones, mostly they'll ask the frequency or this time period or at maximum distance problems. That's what I've observed. If you have observed any other else, please do let me know in the comments, then we'll do that also, right? So I'll see you in the next video with another example on the same topic, that is Coulombic force between two charges, right? Thank you very much.